my god. So, we are going to be factoring based on conjugate pairs, but what you'll mostly hear me say it as is the difference of two perfect squares. But for short, I like to call it dots. So the method of factoring we're learning today, the fancy way, is factoring based on conjugate pairs, but I just call it dots, and it'll make sense once you look at it. So, before we factor, let's just look at the product of two binomials. So if we look at example A, we have x plus 5 times x minus 5. So those are considered conjugate pairs because it's the same thing, but one has a plus in the middle and one has a minus. And you'll see that with all of those pairs. X minus 2, x plus 2. It's the same pieces, just the signs in the middle have changed. Same with C, D, E, and F. So all of those, that's my train of thought, are conjugate pairs. So something interesting happens when you multiply conjugate pairs. So I'm just going to use the traditional method, but if you like multiplying binomials using the box method, that is fine too. So we get x squared minus 5x plus 5x minus 25. So when I get to here and I go to combine my like terms, my middle two terms cancel each other out. So I'm really just left with x squared minus 25. So this is what I'm referring to as dots. The difference of two perfect squares. X squared is a perfect square and 25 is a perfect square, and there's a minus sign in the middle. So difference of two perfect squares. So when I say factor that with dots, that's what you're looking for. But let's just practice a few more just so we can see that middle term canceling out. Actually, I'll show A with the box method, just in case that's the method you prefer. So I'll show both ways. And again, I don't really care which method you pick. If the box works for you, cool. If the old school method works for you, rock on. Whatever makes you happy, okay? So, x times, remember we do box method, we go down and across. So x times x is x squared. Then we have x times 5, 5x. X times negative 5 is negative 5x. And then we get negative 25 in the last. And just like before, we have like terms, but they cancel each other out. So we're still just left with x squared minus 25. So it was the same for both. I forgot to box in my answer. Okay, so let's try that again. Okay. So we distribute, we get x squared plus 2x minus 2x minus 4. And then we have our like terms in the middle. So we get x squared minus 4. So again, that middle canceled itself out. Nothing too earth-shattering there. Let's try another one. Example C is not just an x, it's a 4x. So here we get 16x squared minus 4x plus 4x minus 1. And then we have our like terms. So we get 16x squared minus 1. And just like the other two, both pieces of this are perfect squares. 16 is a perfect squared, x squared is a perfect squared, and 1 is a perfect square. So therefore we still have the difference of two perfect squares. Let's see, let's try one more. Let's do D, because D is just all letters and no numbers. So that one's a little bit more exciting. If I'm going too fast, just tell me to slow down. Big yawn. All right, so we get x squared minus xy plus xy minus y squared. These two are still like terms because they're both just an xy, and they do cancel each other out, so we're still left with x squared minus y squared, which is the difference of two perfect squares. X squared is a perfect square, and y squared is a perfect square. So, really, there's a shortcut to multiplying these. If you recognize that you have a conjugate pair, it's the same junk, different signs in the middle, We don't even have to show that middle step where I highlighted. We can just go bam, right into the answer. So let me show you what I mean. So I'm going to scooch down. So this is going to be the shortcut right here. So I do want you to write that down or highlight it if you printed this out or box it or star it, whatever makes it stand out to you, okay? So a plus b times a minus b, those are conjugate pairs. Same junk, different signs in the middle. So really, if you were to double distribute that out, the middle stuff, the ab's would go away. So you're really just left with the first p squared minus the second p squared every time. Every time, which is kind of cool. This is a cool shortcut. And you don't have to memorize the shortcut by any means. If you like double distributing out or showing your box, like roll with it, you know, do what works for you. So if I use that shortcut, what I really have here is x squared minus 6 squared, so x squared minus 36. Bam. That's it. Had I done this, so what I have in pink is the shortcut way. I'll put in navy the longer way. So the longer way would have been x squared minus 6x plus 6x minus 36 with that middle going away. So it works out. And this only works with conjugate pairs. Only works with conjugate pairs. So let's try another one. So if I'm using that same process, I'm just left with the 5x squared minus the 2 squared. So I keep the order the same. So then I'm left with 25x squared minus 4. And notice that I put the whole 5x in parentheses. If I didn't put those parentheses there, I'm technically only squaring the x, but I need to do 5x times 5x, okay? So that's our little shortcut. Let's do another one. We have 2x squared minus 7y squared. So that's going to give us 4x squared minus 49y squared. And again, this is just a shortcut, okay? But it is important to keep the order the same. I wouldn't have wanted to switch those. If I wrote 49y squared minus 4x squared, it's not equivalent. Okay, you got to keep the order the same. And that's important when we get down to an example like letter D. So with letter D, the 4 comes first, not the x this time. It's still a conjugate pair. It's still the same junk, different signs in the middle. So it's still conjugate. So really here I have 4 squared minus x squared. So 16 minus x squared. And that'll happen. Sometimes the variable won't come first and it's all good. You know, don't panic. Just keep your order the same. No big deal. And again, all these answers that we're getting for these are the dots. The difference of two perfect squares. Because 16 is a perfect square, there's a different sign, and x squared is a perfect square. Just like above here, 25 is a perfect square, x squared is a perfect square, there's a different sign, 4 is a perfect square. Okay, we'll do one more shortcut, and then we'll actually get into some factoring. So we got to keep our order consistent. So since the 6 came first, the 6 has to come first down here, drop my minus sign, and then the whole 5y gets squared. So we have 36 minus 25y squared. 36 is a perfect square. There's a different sign. 25 is a perfect square. Y squared is a perfect square. So nothing too shabby. And again, that's just a shortcut. But the shortcut helps us realize how to factor these pretty quickly. So we're going to be going backwards. In these next examples, I'm going to be giving you the difference of two perfect squares, and we have to figure out what would it look like in that factored form, in that double bubble form. I call this double bubble because there's two bubbles. And you're going to hear me say that a lot more next week. So double bubble just means drop 2 sets of parentheses down. Okay? Because the parentheses kind of look like bubbles. So that's how I say it. Ah, my iPad froze. Gay disaster. Why are you freezing on me? Sad. It's charged at 65%. Aha, there we go. All right. So we are going to be taking these perfect squares and we are going to put them in the conjugate pairs. So same junk, different signs, okay? And again, this method, I like to call it dots. So we're going to go from something like a squared minus b squared to a plus b, and then a minus b. Or the other way works fine. It's also equivalent if you were to say a minus b, a plus b. As long as the a is first and the b is second, whatever one has the plus and minus doesn't really matter. Okay? I usually do plus minus just because I'm brainwashed, and that's how I've always done it. So, shall we begin? So we're going to drop down our double bubbles. So I'll even write this down. So 1, drop down the double bubbles. And insert your plus minus. Insert plus minus. After that, we have to figure out how can we break apart the x squared and how can we break apart the 81. So, x squared, the only way it can be broken up is x times x. And then 81, I need the same number multiplied by itself, so what's the square root of 81? It's 9. Bam! We factored it with dots. So I guess step 3 would be identify conjugate pair. Now, excuse me, if you're not sure if this is right, there's a couple ways we can check it. You can double distribute or use your box method and see, do you get x squared minus 81? Or, if you're a little more tech savvy, you could plug x squared minus 1 in the y1 of your calculator, and then our factored form in y2 in the calculator. And when you look at the picture, it should line up perfectly. Nothing should be like crisscrossing. You should have the same curve each and every time. Now, it's going to get a little hairy if we have more than one variable, but for this case, it works out just fine. Okay, so let's try that again. So, and also when we're looking at these, we need to make sure that every single piece is a perfect square. So with letter B, 9's a perfect square, x squared's a perfect square, there's a minus sign, and 4 is a perfect square. If that had said 9x squared plus 4, we couldn't do it because it needs to be a difference, okay? So we're going to drop down our double bubble, insert the plus minus, and then we need to break up each of the pieces. So 9x squared needs to be broken up into its square root. So 9x squared, square root of 9 is 3. X squared can be broken up into x and x. And then 4, the same number that multiplies by itself, or the square root of it, would be 2. Bam! Conjugate pairs. Same junk, different signs. Same junk, different signs. And again, you can check this in your calculator, or you can multiply it out. It works either way. Okay. Let's try that again. So this one's interesting because we don't start with the variable, but it's okay. 25 is a perfect square. There's a difference, and y squared is a perfect square. So we can use dots to factor. So I'm going to drop down my parentheses, insert my plus minus. 25 can be broken up into 5 times 5, and y squared can be broken up into y times y. Bam! Conjugate pairs. So exciting. So exciting. All right. Let's try another one. Ooh, D's a little festive. All right, so first we got to think, is every piece of this a perfect square? 4 is, x squared is, 81 is, y squared is, and there's a minus sign in the middle, so I am good to go with dots. So I'm going to drop down my double bubble, and I'm going to insert my plus minus. And then I got to think, how does 4x squared break up so that it's the same in each? That'd be a 2 and an x. And then 81y squared, that would be broken up into a 9y and a 9y. So conjugate pairs, same junk, different signs. Same junk, different signs. Okay. Let's do it again. 121 is a perfect square. X squared is perfect square, and 1 is indeed a perfect square as well. And there's a difference. So drop your double bubble, insert your plus minus. The 121 x squared can be broken up into 11x and 11x, and the only way to get 1 is 1 times 1. So bam! Conjugate pairs. Very exciting. One more, and then we'll call it a day. Okay. 1's a perfect square. There's a difference. 4 is a perfect square. And x squared is a perfect square. So we're going to drop down our double bubble. Put your plus minus. The only way to break up 1 is 1 and 1. And 4x squared can be broken up into 2x and 2x. So bam. There you have it. Conjugate pairs. So, I will, once I click off this video, I will post the homework in Delta Math. I forgot to hit click this morning, so I'm going to do that as soon as I click off this video. But hopefully it wasn't too bad. And feel free to rewatch it if you need to, or join me on my office hours, or email me. I'm always here to help you. Mr. Van Remmen can help you as well. And Ms. Wilcott is back from maternity leave, so she also has some Zoom office hours. So you have 3 people minimally to go get some help if you need it. Hopefully it went okay. So I hope you have a fabulous rest of your day, and I'll see you next week. Bye.